I request everybody to be please take your seat. We would like to start the session. The last session for the day is on OPA, Open Process Automation, and we have around 6 speakers in this session. First speaker will be from ExxonMobil. ExxonMobil's OPA Lighthouse project and commercialization plan update by Mr. Whitt McConnell, Chief Automation and Process Control Engineer, ExxonMobil. He'll be speaking for 20 minutes. And the next presentation by Reliance, by Sunita Devi, Group Lead for Open Process Automation, and she'll be speaking on Reliance OPA test bed updates and future roadmap. And she also will be speaking for 20 minutes. And the third presenter will be Mr. Ravindra Jagashia, OPF Forum Co-Chair. He'll be giving the update on the OPF. And the fourth speaker will be from Yokogawa, Mr. Mark Hammer, Lead for Open Readiness Center, Yokogawa, and he'll be speaking on Yokogawa's approach to OPA. Then we have again Mr. Ravindra Jagashia on behalf of our stall group. He'll be speaking on implement OPAs in the hazardous areas. And the last speaker will be Mr. Praveen Kumar Singh, Chief OPC Solutions Architect and OPC Foundation Accredited Expert from Uttunga. He'll be speaking on engineering for the open era, building multidisciplinary readiness for OPAs. So I would like to request Mr. Whitt McConnell, Chief Automation and Process Control Engineer, to come on the stage.
So first off, I'd like to thank ARC for inviting me to come in and giving me 20 minutes to speak to you. It's my honor to give you an update on what we've been up to with OPA and where we are. I wanted to start off with a little bit of background about me. So I am the Chief Engineer for Automation and Process Control in ExxonMobil. I've been in the corporation for about 26 years. I started off as a control systems engineer. And so this is back in the late 90s, and I've seen such a change in this space from a technology evolution over time. You have to understand, when I started, DCSs were entirely proprietary. All of the hardware, all of the software, there wasn't really this concept of having Dell servers and Microsoft operating systems. That came later. In the old days, it was pretty stark. In terms of the technology. The system that I looked after, there were 5 or 6 of them at the time, and I started off in the Baton Rouge chemical plant for ExxonMobil. It was a mainframe supervisory control system over TDC 2000, Honeywell's TDC 2000. And it was all coded in assembly language. It was pretty archaic. It was essentially 1970s, early 80s technology. And we were running it with a DEC Alpha on top of it. And that was running the early MPC, so early DMC for model predictive control. And that was pretty much the environment, right? So we've evolved since then and moved into, at the time we called open systems, which was really bringing in more commercial off-the-shelf technology like servers and workstations and Microsoft operating systems. And that did allow for a real explosion in innovation and evolution in the control system space, and that's been exciting. A number of the optimization technologies, RTO, model predictive control, process historians, operator advising systems, expert systems, all kind of came into that level 3 space, and all in like a Microsoft package for the most part. So we learned all about Active Directory, we learned all about Ethernet networking. We were there for the early days of OPC, what's now called OPC Classic. At the time it was just OPC, primarily DA. And in the early days it was kind of rough. Not to speak badly about OPC, what I see from OPC UA today is leaps and bounds ahead of where we started. In fact, we used to call OPC, we thought that acronym really meant "Oh, please communicate," because it it always took a while to get a new client to talk to a new server. Anyway, so that's a little bit of my history. I've been in that space for branched out. I've done some other roles in the corporation, and then I find myself in this role, which goes beyond control systems. It's really instruments and safety systems. It's all of the advanced control where our applications folks live. And so it's all of those things. I took over for a fellow named Don Bartusiak. You may have heard of that name. He's kind of credited with starting the whole concept of OPA. And it wasn't him by himself. It was actually a team of very smart engineers out of ExxonMobil. I was actually in some, not that I'm calling myself smart, but I was in some of those early discussions kind of helping to frame out what eventually became OPA. But I think it's important to go back to the motivation of why did we even start talking about OPA? I mean, if you think about it, what we're trying to do is very ambitious. We're essentially trying to change a whole industry, right? The way that DCS systems are designed and marketed and used. We're trying to reshape that from the ground up. That's no easy task. As was mentioned before, it's something we can't do on our own, and so trying to help build the desire for more open and interoperable systems is something that we've been talking about for quite a while. But we didn't go down this path just to do that, right? Just to shake up industry. We went on this path for some very specific reasons. It was about 2012 or so that we had some indication that we were going to face an obsolescence problem in a pretty large part of our fleet of DCS. Well over 100 DCS systems were going to be obsoleted by the vendor at the end of this year. So the end of 2025, these systems were to go obsolete. Now, you might look at that and say, oh, well, that's 13 or so years from now. Like, why are we worried about that? Well, 100 systems, right? So that it was really the scale of the problem that had us concerned. And in ExxonMobil, we're pretty good about looking at all of our equipment as a fleet of equipment and trying to manage it in a holistic and comprehensive manner. But there's some downsides to that, right? So as we looked at what it would take to manage that obsolescence problem, we had to look at what the technique at the time was to do that. The systems were old, they were no longer going to be supported, and so what do? Well, we do, or what we were thinking about doing, is what we affectionately call a rip and replace. Rip out the old system, replace it with the latest, greatest technology, and off you go. Sounds simple, right? Well, the devil's always in the details, and there's a whole lot that goes into that, right? So rip and replace is a very expensive endeavor. And you have to understand that it's not the system itself, right? Going and buying the system, while it's expensive, is really the cheapest part of all of that. It's really transitioning all of the control programming, the control narratives, the HMI programming, putting that into the context of the new system, and then having to move control wire by wire, loop by loop, from the old system to the new system. And oh, by the way, now I have to have 2 operator posts. I have to double man those for the whole duration of that because we want to do this online. We don't want to shut a unit down to be able to do this in a matter of weeks. That's not affordable. So this takes months, and you are double manning and in this weird position where you're controlling part of the plant on one console and the other part of the plant on the other console. It's a very uncomfortable place to be. Other aspects, you're going to move the console or create a new console. You're going to move certain pieces from one console to the next. A lot of the consoles that we built in the 70s and the 80s, we did in the manner of the time, which was to build a customized stainless steel that fits the bezels of the 4x3 screens that were popular at the time, right? It's not very forgiving, or it doesn't allow you to evolve your technology in a manner at all, right? It's you basically have to demo this, what looks like a tank, and it's very sturdy and durable, and it takes a lot to demo that thing. But that's not the hard part. The hard part is we've embedded like safety shutdown buttons. we've embedded P1 alarm light boxes, we've embedded radio systems, and so all of those have to be moved. And so if you imagine an emergency shutdown button and trying to move it from one console to the next without tripping the plant, pretty scary proposition. So all of this takes an immense amount of engineering and planning and then flawless execution. Okay, that's one system. Look at that across 100, and what you're talking about is a decade to a decade and a half to get it done, and you're talking about an expense of somewhere in the billions of US dollars. That's B, billions with a B. Okay, I don't know how your company is, but when I approach senior leaders and ask them to spend that kind of money on a project that I can't really give them any specific return on just for migrating from one system to the next, they kindly, or not so kindly, ask you to leave and come up with a different solution. Okay, and that's what happened. So we basically went off and took two tracks. One track was to go and, hey, let's work with the vendor and come up with an alternative to rip and replace. Okay, I'm not going to talk about that. The other track was, well, if we had to rip and replace, right, what are our options? We can rip and replace to the latest generation of the current vendor. We could go to any other vendor. And so we could have a bake-off and decide, well, which vendor today is kind of ahead of the other vendors. And what we've seen over time is the vendors are all evolving their systems, and they're very, very good. At any point in time, one vendor might have something that's a little bit better than the others, but in the fullness of time, they kind of catch up to each other and surpass sometimes. So you never know, and so it really doesn't matter. Sorry, Yokogawa and ABB and others in the room. I don't mean that in a derogatory way. Love you guys. So that was an option, but we decided, well, listen, if you're gonna like white sheet this, what would be the system of our dreams, right? What would that look like? And we didn't know, but that's where we started pulling people together and just like, if you had to build a system from scratch, what it would look like, what characteristics would it have? How would it address some of the business objectives that we're trying to address? How would it reduce cost? How would it address some of the other pain points involved with having a DCS? And that's really where this came from, right? So we settled on, hey, we really want things to be open. We want things to be interoperable. We want to have more optionality when we purchase and settle on a system, so that we're not necessarily kind of caught within just the single ecosystem of a particular vendor, right? We wanted more optionality. Okay, when I think about what we were trying to do, it kind of comes down to a couple of things, right? Ultimately, all of those things are cool, right? Open, interoperable, it gives me optionality, I can do all kinds of things. But from a business outcome, what I'm really trying to do is take cost out, right? I want to make it cheaper to own the system. I want to make it cheaper to buy. I want to make it cheaper to implement. I want to make it cheaper to sustain. And I want to make it cheaper to lifecycle manage. And I want to make it cheaper to change if I wanted to change a particular aspect of that system, right? So those were key elements. And the whole idea around openness and interoperability helps to address a number of those things. And it really reduces that barrier to change. I mean, that's a really big one. When you talk about interoperability, it also plays a role in some of our digital transformation thoughts. You know, you've been hearing a lot around IT-OT convergence and being able to connect to a number of different systems and exchange data, right? The more open you are, the easier it is to convey that data and be able to get it to a place where you can use it to do deep analytics and other wonderful things that we're hearing around AI. And I'm sorry, I was promising myself not to use the word AI during this, so, because I'm not talking about AI. So either you're going to find this as a break or you're going to be a little bit disappointed. But it certainly will be an enabler to some degree, and we think that that's an important piece. And that really brings me to the second point on this slide, is We want it to be cheaper, but we also want it to be better. We want to modernize the automation architecture, right? So that we can enable new things that we hadn't even thought of at the time. And to be honest, when we started thinking about OPA and what it could be, we weren't specifically thinking about AI. But as that space started to evolve, it's kind of a natural fit, right? If I have an ecosystem that kind of merges level 3 and level 2 together, right? It kind of compresses the Purdue model. It really does allow me to do some things closer to the valve than we've ever done in the past, right? If I'm able to bring more compute horsepower to within the system, it really enables me to do things that I really couldn't do before, or I couldn't do within the confines of the DCS itself. Being able to modernize a system also helps us in how we deploy that system, how we evolve that system over time. If you think about what we've had to do in the past, whenever there's a new version of your DCS software or firmware or hardware, you had to do what was called an on-process migration, right? This is a very intensive exercise to move from one version to the next while you're running a unit and not causing bad things to happen to the unit, right? No loss of view, no loss of control. That takes a lot of effort to do. When you look at some of the composable, container, orchestrated type systems, more software-defined systems, a lot of that becomes much easier. With that type of a componentized system, with clearly defined interfaces, there's a little bit less risk of making a change in one piece of the software that has an unintended consequence in another piece of the software, because I'm working on just a single piece of it, right? So it makes being able to evolve the system much faster a possibility, right? So these are some of the key elements that we were looking for in OPA, and those were the business outcomes that we were aiming for. So we've been on a journey. We've been talking about OPA for a long time. I'm sure you've heard us speak in a number of different forums to talk about this idea of OPA. Working with the open group and helping to create the OPA Foundation, or OPAF, has been a key part of that. We've developed test systems, proofs of concept. We have worked with partners like Yokogawa to develop a field trial system, test system, so that we could build a system that came into being and is actually running one of our plants today. So at the end of 2024, we commissioned a first-of-kind OPA DCS on a resins finishing plant in Baton Rouge. Right, it's about a 1,000 IO system. It has a lot of the elements that we've been looking for in an OPA type system. Right, it's all virtualized, so we've separated hardware from software. That's a key part of it. How system management happens, orchestration. OPC UA is, of course, the foundational communications infrastructure within the system. And it's all container-based. How we do the logic execution using 61499 protocol as that part of the environment. So it's done, it's real, it's running the plant today. I made this announcement in the ARC Leadership Forum in Orlando in February. It was very exciting. Probably the most exciting thing to me, being a former systems engineer, was that the systems engineer responsible for that system's health was sitting in the audience as I was giving this discussion. Now, you might not think that's much, but what that tells me is that the system was running reliably. I have put in early versions of systems that did not run as reliably, and I have, on occasion, brought a sleeping bag to sleep next to the system so I could restart it and fix it whenever it fell over. So I was very proud that the systems engineer was in the audience with us a long way from his home site. It really helped me to believe that, hey, we'd really taken the system to a new place, right? This was serial number 1 of a system. I was really expecting it to have a lot of issues. And it wasn't issue-free. It had some, but they're not major issues. So this was a screaming success. Okay, so just a brief rundown on some of the things that we learned putting this system into place. We had a very effective team of ExxonMobil folks, along with some Yokogawa folks. We had Schneider folks. I think we've had some Red Hat folks. Gosh, I want to mention everybody that's at least in the room. And the team was very focused on making sure we tortured that system beyond what we expected to have it in the field. And that's probably a reason why the system engineer was able to be there with me while we had this first discussion. And so they tested that system very hard. There's a lot of new things to learn in building this system. So it can be a lot of work. It's a bit of a learning curve to figure out how to code control narratives in 61499. And there were other tools that the team had to learn. It was a journey and they gained a lot. They are really experts in this space now. It's amazing to see them grow. Rethinking how to build a process control system using these types of technologies can be liberating. For those of us that work in the DCS space, you know you have to live within certain confines of the system. And so a lot of those are relieved when you start looking at some of these new paradigms in terms of how to build and deploy a system using modern technology. This is that IT-OT convergence that we were talking about before. Phrases that the console operators uttered during the deployment of the system. It works. Okay, that means the plan is going to continue to run. That's great. It works better than the old system, just like we said it would. So happy to hear that. I was worried, which meant, okay, the bad things didn't happen, so the engineers can stay. They're not fired. And can we make enhancements and changes, which means we like it, and how can we make it better? So quite frankly, very positive feedback from a group of folks that are typically kind of cynical, particularly when you change out the system that they're used to operating on. So we were pretty pleased with that. So what's next? We're going to continue to look for opportunities to use OPA principles and OPA aligned solutions within ExxonMobil. So this is part of what we're calling our commercialization strategy. We have a ton of PLCs in our environments, many of which are also going obsolete. So there's a number of brownfield opportunities that we're going to look at to apply some of these OPA solutions. We also have some other smaller DCS opportunities similar to like what we've used at the finishing plant. Those will be opportunities to do that. So these are smaller, lower complexity, right? You want to start simple and grow from there. And we're looking for more OPA aligned products to be made commercially available, right? This is something that has to grow, and it has to grow based on the demand of the user community, right? And so this is a calling to all of us. If you really want to see a change in this, if you believe that, hey, going to more of an open and interoperable architecture is a benefit to all of us, then we all need to be asking our vendors to start moving in that direction, right? They're not going to do it, well, I say they're not going to do it on their own. They will do it where they see there's a market, and that's fair. And I think we have to present that, hey, we're interested in providing that market. So in summary, and I'm a little beyond my time, and I apologize, but this is a fast-moving space. The automation space has been evolving forever. It's evolving faster now, it feels like to me. There's so much going on, and again, I didn't mention AI, but AI is going to be even more of a game changer in this space. So it behooves all of us to kind of keep an eye on this and continue to guide and direct our technology providers to really helping us solve the real business problems. The first OPA-based DCS system is deployed on process. It's real. We did it. So who's next? And I'm hoping it's Reliance. All right, thanks very much.